So now that I've introduced the concept of result ordering, let's talk about the way in which different kinds of collections or different kinds of data sources and different types of aggregate operations are going to influence the way in which the processing takes place in the ordering of the results. So we'll start by talking about collections that affect results order. And we'll look at a bunch of examples. All of these examples are from my EX21 folder from my GitHub repository. So if you want to go ahead and take a look at this stuff and play around with it and see for yourself how these different approaches work, please feel free to go ahead and clone and run along or run these application examples in EX21. So encounter order is maintained through several different means. One is by using so-called ordered split iterators. Another is by using so-called ordered collections. And yet another is by using the so-called static stream factory methods. So there's a bunch of different things. We're going to talk here primarily about ordered collections. And if you take a look here, you can see the example. So the example we're going to use here has a list of integers, and we get this list of integers by using arrays.asList, and that's going to make a list that's going to have the elements 2, 3, 1, 4, 2 in that order. So a list, especially an array list, which is what we're doing here, is an ordered collection. So the order matters. So it's 2, 3, 1, 4, 2. And the reason this works is because the list is an ordered data structure. And in this particular case, it's also non-unique. So you can have duplicates, like we have 2 values of 2. And when we talk about other kinds of collections, like a set, for example, you see that they have different characteristics. They're not ordered and they're unique. So we take our list in the order 2, 3, 1, 4, 2, and we convert it into a parallel stream. Now remember again that ordered is not the same thing as sorted. This is not a sorted list, it's an ordered list. So then we go ahead and convert that ordered list into a parallel stream, and then we're going to go ahead and apply some intermediate operations, starting with filter. So what we're going to do here is we're going to get rid of anything that's odd. So we're only going to allow even values to continue. So we winnow out, we sift through the set of elements that are in our original list 2, 3, 1, 4, 2, and we're only going to have 2, 4, 2. Those will be the things that will pass the filter here. And then we go ahead and apply the map operation, and what we're going to do there is multiply each even number by 2, so it'll end up being essentially 4, 8, 4. That'll be what comes through. And then the last thing we're going to do is we're going to convert the stream, which is 4, 8, 4, into an array of integers. So notice how clean and cool this is. This is one of the great things about collectors and terminal operations and so on. You can do some really neat stuff. We don't have to allocate any memory ourselves. The collector handles all of that, and so on and so forth. So you can see here we use the toArray terminal operation, passing in an array constructor reference. So integer array : new is the syntactic representation of something that will make a new array. And of course, that new array will contain the elements 4, 8, 4 in that order. So that's what's going to come out. So the results here have to be ordered as 4, 8, 4. It doesn't matter whether the processing took place in some other way, whether the 8 was multiplied first before the 2 4s or whatever, or the 2 4s were processed before the 8. Doesn't matter which one's finished first as part of the apply phase. As part of the combine phase, things are put back in so-called encounter order. So the list will end up being with the results 4, 8, 4 in that order. All right, so that's one example. Let's take a look at a different example. So over here, we're going to use an unordered collection. So the way we're going to do that is we're going to take our same list, which we had before, which is 2, 3, 1, 4, 2, and then we're going to go ahead and put that into a hash set. And if you recall, a hash set has a couple of interesting characteristics. First characteristic of a hash set is the fact that it's going to be unordered. So there's no particular ordering with hashing because it just hashes the values and they go into the data structure in whatever way the hash function will put them. And secondly, since it's a set, that means that the values are unique. So we know that they'll only have the values 1, 2, 3, 4, but they could be stored in the hash set in whatever order it happens to hash to, whatever the hash function is. So it's not guaranteed to be sorted. It's not guaranteed to be ordered. There's no particular ordering, and they'll also be unique. So some of the elements will drop out. So we do the same computation that we did before. So this is the same fluent pipeline of aggregate operations, but the output can be in whatever order it happens to complete in. So if it turns out that 8 gets done before 4, the result will be 8 and 4. If it turns out that the 4 gets done before the 8, the result could be 4, 8. And the reason why it doesn't matter is because the collection itself is unordered because it's a hash set. And as we also see, it's going to have to be unique. So this code might actually run faster, maybe, because it doesn't have to obey anything to do with the encounter order. And we'll actually see if you run some of the tests that are in the EX21 example, you'll actually get a chance to see which ones run faster when we turn off the ordering constraint. And I'll show you how to do that shortly. So that's just a quick overview that kind of demonstrates and compares and contrasts two different types of collections, one of which was an ordered collection, an array list, the other which was an unordered collection, which was a hash set. So those kinds of things can make a difference, both in terms of performance and also in terms of the semantics of what you get as the result and the order in which you get the results.